Wait, are we gonna have lab time?
No. Probably not. Okay. So, what we're going to do is we are going to do some calculations involving s'mores. All right, just to remind you what a s'more is made out of. It's made out of these marshmallows. It's made out of these chocolate bars. It's made out of these graham crackers. So the first thing that we had to do is we actually constructed a new periodic table. A periodic table of our food ingredients, right? Which were marshmallows, graham crackers, and chocolate bars. And just to make it look like the periodic table, I put a little atomic number on there. The atomic number has nothing to do with anything but where its position is on the periodic table. All right, it's really the number of protons, but marshmallows don't have, we don't even care about how many protons are in a marshmallow. Okay, what we do care about is
The atomic
masses, the average atomic masses, which, when you weighed them, what'd you get for the marshmallows?
6.77.
7.8, 6.7, 7.00, all over the place. I'm going to say 7.15 is sort of a rough estimate of the average there, okay? Now you said it was the average atomic mass. Are you going to make an atomic s'more?
No.
A nano s'more?
No.
No. We don't want to make a s'more out of one molecule of marshmallow, or sorry, one atom of marshmallow and a couple atoms of graham crackers. So we're going to assume that this actually represents a mole of marshmallow atoms, right? Or marshmallow particles. Okay? So instead of this being the average atomic mass, we're going to call it the molar mass. That's the mass in grams per 1 mole. Okay? Graham crackers, what'd you get?
3.84 grams.
3.81.
3.8, 3.7,
3.84.
3.8. Okay, I'll call it 3.75. Cool. And then chocolate bars.
3.33.
3.05.
3.34, 3.3, 3.0. We'll call it 3.10. Okay, so those are the molar masses. Those are what the individual pieces weigh. Okay, but when we make a s'more, we're not necessarily making it out of these individual little atomic pieces of the s'mores. Right? What are we making it out of? Well, to make a s'more, I need one of these, right?
Oh, you need more than one.
What is this?
2.
That's like 2 little pieces of graham cracker put together, right? That would be the base of my s'more. So I'm actually, as far as a reaction goes, I'm actually using these.
Yeah.
Okay, so the analogy I made was like, when I burn something, what am I combining it with?
Oxygen.
Oxygen. Do we find oxygen as just O? It's O2, right? So some elements naturally exist as molecules. Graham crackers naturally exist as little molecules that we're going to call GC2s, right? Marshmallows, how do they exist? Just one. They're just little marshmallows all separate, right? Okay. And then chocolate bars.
2. CB2. 3.
I don't think I let you open up these packages, but
4.
there's actually 4 of them connected together. Okay, so they don't exist as these little pieces, they exist as 4 of them stuck together. Okay, now we're going to turn those things into a s'more. Now a s'more, has everybody in here made a s'more before?
Yep.
Has anybody not made a s'more? A student from Mongolia in the last class never made a s'more. They don't have s'mores in Mongolia. Okay, so if you've made a s'more before, you're going to take one of these, which is a GC2, right? We're going to make a nice s'more, so we're going to take 2 chocolate bars, put it together on there, right? We're going to toast our marshmallow, then add it, then we're going to put another one on top, right? So if I think about what are the total amounts of things in a s'more, what does it actually have? Well, it has one marshmallow, right?
Yeah. 8 chocolate bars.
It actually has 8 of these little bits of chocolate together, right? And how many graham crackers?
4.
4. So it's really like a graham cracker 4, chocolate bar 8. So in terms of the individual little chunks that we measured here, this is the formula of a s'more. Okay? Now, there's a problem with this recipe.
There's no
Not balanced.
coefficient.
Not balanced,
Okay.
right? We don't necessarily need coefficients unless it's not balanced. And it's for sure not balanced because we got 4 chocolate bar pieces here, we got 8 here. So how do we balance this thing?
Put a 2 in front of it.
We need a 2 in front of the,
Coefficient.
Graham crackers.
and for the graham crackers, right? So that makes sense based on what we're looking at, right? Because we know if this GC2, this is a graham cracker, we know we need 1 for the top and 1 for the bottom, right? If this CB4 is a chocolate bar, we know we're going to put 2 in there per s'more, right? Okay. Now, this equation, what is it telling us?
1 marshmallow plus 4 graham crackers plus 8 chocolate bars equals a s'more.
Yes. Or another way of saying that is 1 marshmallow plus 2
Graham crackers.
graham cracker squares
Oh.
plus 2 big chocolate bars, right? Gives us 1 s'more.
Yes.
Now, what scale are we talking about here? We said this is
units?
not really a marshmallow,
It's a
this is
mole.
really a mole of marshmallows,
Also like
right?
units.
Okay, so yes, we could make a nano s'more and take 1 little particle of marshmallows, 2 little particles of graham crackers, 2 little particles of chocolate bars and make a little nano s'more, right? But we're going to scale that up. I could scale this up to any amounts that I want. I could take 1,000 little bits of marshmallow, combine it with,
Graham crackers.
how many graham crackers?
1,000 bits.
2,000, right? If this takes 1,000, I need 2,000 of these, 2,000 of these, and I can make 1,000 tiny little nano s'mores, right? We're going to scale this up to a mole. If I take 1 mole of marshmallows, combine it with 2 moles of graham crackers and 2 moles of chocolate bars, I'll get 1 mole of s'mores. Okay? So this is in moles.
Nice.
Again, I could keep it in particles, atoms, or molecules, but am I ever going to actually do a reaction with that few things?
No.
No. But we need to understand that on a fundamental level, that's what's actually combined when we do chemical reactions. Okay? Now, the questions I really want to be able to answer. One question is, given an entire package of marshmallows, how many s'mores can I make?
How many marshmallows?
Yeah,
are
how
in
many
the package?
marshmallows are there?
4. On that. 4.
Okay, well, the first thing we have to know is what does the package have in it? 283 grams. So this should be easy, right? 1 marshmallow, 1 s'more, 283 grams of marshmallows, 283 grams of s'mores, right?
No.
Why not?
Because that's in moles, that's in grams.
This is in moles, that's in grams.
So you have to convert it.
So first we got to convert it
Yeah.
to moles. How do we do that?
Separate proportion.
Set up a proportion. What is the proportion going to look like?
283 grams over X moles
Yeah.
equals 6.7. Oh, the molar mass, or whatever you have, and then over 1 mole.
Over 1 mole. Okay? Now I can set it up that way, but because I really want to know the moles
Oh, for the-
of marshmallows, let's put that on top. Let's say how many moles of marshmallows are proportional to 283 grams of marshmallows if periodic table tells us that 1 mole of marshmallows is proportional to 7.15 grams. Okay? You could do it exactly the way that you told us to set it up. It's just going to be a little bit more complicated to solve. Okay? So, let's solve it. What do we get?
283 equals 7.15x,
You can cross multiply if you want.
and then divided by 7.5.
Sure. You can solve this algebraically. If x is being divided by 283, undo it. Multiply both sides by 283. So 1 over 7.5 times 283. You get the same answer. What do we get?
So 2022.
2023?
45.
Let me check.
What'd you get? 39.
Yeah.
Jasmine, what'd you get?
You said multiply. You should have done that.
Huh?
Still like 100.
It's set up for you. You're not writing, you're calculating. I told you, don't write anything.
39.58.
39? Wait, who got 2,000?
I think.
Because you multiplied.
Yeah, I saw a lot of you not so sure on your algebra. How do we know it can't be 2,000?
Because 7.15 doesn't go to 283 2,000 times.
If each mole is 7 grams, 283 grams can't be 2,000 moles, right? Okay. The other reason is, what are we actually calculating? What we get? What'd you get? 39 point. We're saying this is 7 grams. This can't be 2,000 marshmallows, right?
No.
Could it be 39 marshmallows?
Yeah.
Let's check the package. The package says serving size 4 pieces. Servings per container about 9. 9 times 4 is 36, which is pretty close to what we got, right? So yes, there are roughly, according to our calculations, 39 to 40 marshmallows in there. Okay, it depends on whether each marshmallow weighs the same amount and blah blah blah. Okay, this is how many moles of marshmallows. That's how many marshmallows are in there, right? But what are we trying to find? How many graham cracker, or sorry, how many s'mores can we actually make? So how am I going to do that?
Just convert it to s'mores.
How do I convert it to s'mores?
Proportion.
Setting up a proportion. What proportion am I going to set up?
You're going to take your moles and you're going to put it over your X amount of s'mores, and you're going to equal it to 1 marshmallow over 1 s'more.
I'm just going to flip that. We're setting up a proportion between s'mores and marshmallows, right? So I'm using Y here so we don't confuse with what I just did. How many moles of s'mores do we get for 39.58 moles of marshmallows? That proportion is fixed. It's fixed by what?
1 marshmallow over 1 s'more? Wait,
By the recipe.
Yeah.
The recipe says for every 1 mole of marshmallows we use,
1
we
s'more?
get 1 mole of s'mores. Okay, so on the right side, I'm going to say 1 mole of s'mores per 1 mole marshmallows. Okay? Now we don't even have to plug this into our calculator.
Wait, why did you? Oh, wait, never mind.
Okay? So this is our sample. This is the equation, right?
Why did you flip it?
Why did I flip it? Just to make the math easier. Because I don't like to cross multiply.
Oh,
Solve for
okay.
y, I just multiply both sides by 39.5.
Oh.
Okay? So we know that we're going to make 39.58 moles of s'mores. Okay? Now, what if we're going to ship those s'mores to the people in Mongolia that never had a s'more before? We're going to need to know how much that weighs, right? We're going to go to UPS and they're going to say, okay, what does your box weigh? We're going to ship it by the gram, right? Charge you by the gram to ship this thing to Mongolia, right? How can we figure out how many grams this is?
You can convert it back. Set up another proportion.
Set up another proportion. That's all we're talking proportion. What would that proportion look like? Well, we want to know, for our sample, we want to know how many grams. Oh, maybe I'll use a Z here since I already used an X and a Y. Let's use a Z. How many grams of s'mores are proportional to 39.58 moles of s'mores? Do we know anything about that proportion?
Wait, that says Z grams.
Z, unknown, yeah. It's my Z.
The
So when you put it over,
the number of grams of s'mores, like the.
wouldn't that just be the
Yeah,
molar mass of
the
s'mores?
283.
S'mores?
The 283.
Yeah, the molar mass of s'mores.
283 on the bottom.
Wait, 283, that's the grams of marshmallows.
Oh.
I want grams of s'mores on top. I want grams of s'mores,
Wait, wouldn't we have to calculate the molar mass of s'mores on
Yeah.
top?
and I want moles of s'mores on the bottom. When I set up a proportion, the units have to be the same on the top and the bottom of both sides.
Yeah.
So yes, the way to figure out the
Oh,
proportionality
one.
between the grams and the moles is
To figure out the molar mass of the s'more.
figure out the molar mass of the
The
s'more.
bottom would be one mole.
Yes, the molar mass is always 1 mole, so let's add it up. What does a s'more actually weigh? Well, a s'more has 1 marshmallow, so 7.15, has 4 graham crackers, so plus 3.75 times 4. It has 8 chocolate bars, so 3.10 times 8. Everybody's going to do that calculation, then we're all going to say our answer together. Broken?
It wasn't working.
You hit second up. Didn't I teach you guys that?
Yeah.
There's only a 6 in it.
Wait, so the last number, 3.10, we multiply by 4? 8.
Here we're doing it for the s'more. What is the s'more actually?
46.95.
We were going to say it all together. Somebody had to ruin it.
Sorry.
46.9.
Yeah.
Is that what you got?
Yeah.
Anybody not get 46.95? Speak now. Forever retain your ignorance.
Did you do 3.75
Oh,
times
Mr.
4,
Bulls.
right?
Yes, we're doing it for what's actually in the s'more. So 3.7 times 4, 3.10 times 8, 7.15 times 1. What do we get? 46.95.
46.95.
Okay? So that's for proportionality between grams of s'mores and 1 mole of s'mores. All right? So let's solve. How many actual grams of s'mores are we going to make?
I don't know how to do it your way again. What do you do? Multiply it.
Well, I just take this ratio, 46.95 over 1,
Multiply by both sides.
and then multiply it by 39.58. Because right now Z is being divided by 39.58. To undo that, we have to multiply by 39.58. But if we do it to this side, we've got to do it to that side as well.
So this one's going to be a big number since it's small.
Should be a big number because it's grams.
So, okay.
So if we think about a whole box of s'mores that we've made,
Yeah.
each s'more weighs 47 grams. If we make a whole bunch, it's going to be more than 47 grams, right? What did you get?
1,858.
1,858?
0.2.
Whatever.
So, anyone? Yeah, Jonah.
All right. So that's how much we're going to make, right?
In
Wrong.
grams.
Wrong.
Oh, now you have to,
There's a problem. Problem is, we have not factored in any of our other ingredients. If I look at my package of graham crackers, we've got 726 grams graham crackers, we've got 293 grams of chocolate bars. What's the total mass of ingredients?
Oh. Like 1,000 something.
1,093?
Yeah. Wait, what? No.
1,305.
We're taking 293 plus 726 plus 283.
Yeah, 1,305.
1,302.
305.
1,302.
302?
I got 305.
Okay, check what you typed in.
It's 1,302.
1302, right? How are we going to make 1,800 grams of s'mores if we only have 1,300 grams of stuff?
True.
It's impossible, right?
You could just like cut it.
Get out of
If you're struggling. Like,
No, the law of conservation of mass says the maximum amount of stuff we can get in is equal to the amount of stuff we get out. The maximum amount of stuff we can make is equal to the mass of stuff we put in, right? So what's the problem with this calculation?
wait, we didn't factor in the other.
It's assuming we have unlimited amounts of the other things, which we do not. Okay? So the other types of questions I might ask you, in addition to saying, okay, given one ingredient, how much of a product can you make, is which ingredient, given a set of ingredients, which one will run out first?
Probably chocolate.
Probably chocolate, since I told you it was going to be chocolate before. Okay? But can we mathematically prove that the chocolate is going to run out before the marshmallows? Well, if we do these sets of calculations again for the chocolate, what's going to happen? Well, again, first we got to convert it to moles. So, X moles of chocolate per 293 grams of chocolate is proportional to what? Anytime I'm going from grams to moles, I'm using?
You're using.
The molar mass.
Yeah.
Right? We got to be careful. Because if I put 1 mole, this is CB4, this is chocolate bars. What does 1 mole of CB4 weigh?
Oh, it was
This weighs 3.10. This weighs
12. Yeah, something like that.
4 times as much, right? 12.40. Okay, so you got to be careful when you're dealing with a molecule that you're using the molar mass of that molecule to actually figure out how much you have. Okay. So how many chocolate bars do we actually have? 23.6. And I would guess if I looked at the package, serving size 3 pieces. Servings per container 8. 8 times 3.
24.
Oh! Man, we're killing it. We're doing so good. Oh, it's nice. All right. Now, I want to convert that to moles of s'mores. So, why moles of s'mores? Proportional to 23.6 moles of chocolate in the same way that the recipe is proportional. The recipe says, what is this proportion?
It's the how much, or it's gonna equal how much of grams.
Look at the ratio. I'm saying moles of s'mores to moles of chocolate. Look at the recipe.
8 moles.
8.
I mean 8.
The recipe says 1 mole of s'mores
Oh.
for 2 moles of chocolate.
Okay.
Right?
Okay.
Yeah.
When we're using the equation,
Over 2 moles of chocolate.
we just want to use the coefficients.
I can't do it that way. I don't know.
Huh?
I can't do it that way. It feels weird when I do it that way.
What do you mean it's weird?
feels weird when I do it.
What would you do?
Because I like cross multiplying.
Oh,
Yeah, me
okay,
too.
so cross multiply away. That's fine. I don't care. It doesn't matter how you set it up, as long as you understand that if I'm setting up a proportion of the moles of things, I get the other side from my balanced equation. I don't care if you have this flipped, really doesn't matter what way you set it up. Okay, question?
Is that supposed to be, on the Y moles, that's supposed to be
CB8, yep. I don't know what happened. Talking and writing at the same time. Okay, so how many moles of s'mores are we going to make with our chocolate?
12. 11.
Calculate it.
11.
11.8?
Can't have 0.8 of this more.
You can't have 0.8 of a s'more, so this is all theoretical, right? But that's okay. Now, that's way less than the amount of s'mores we could make with the marshmallows, right? That tells us that chocolate bars is going to run out before marshmallows, right?
Unless graham crackers.
Yes, we have to do the calculation with graham crackers as well. But between the two of these, with these two numbers, I can tell that chocolate bars is going to run out because chocolate bars is going to limit us to making only 11.8 s'mores. What happens after make 11.8 s'mores? No more chocolate. If we have an assembly line and one person's putting on chocolate, one person's putting on graham crackers, and one person's putting on marshmallows, right? When we make 11.8, the chocolate person's going to be like, I'm out. I'm done. The marshmallow person's going to be like, dude, I got marshmallows for days. Let's go. Let's keep making. They're like, sorry. I don't care how many marshmallows you have. I don't care that we could make 39 s'mores. We don't have enough chocolate to make 39 s'mores. Okay? So, we have a special name for this. We call this the limiting reactant. I'll call it the limiting ingredient. It's the one that's going to limit how much product we can make. We are limited to 11.8 moles of s'mores with the amount of chocolate that we have. Now, we haven't actually factored in the graham crackers, so maybe we should do that for the graham crackers.
I don't think it's going to run out. I don't love it.
Somebody with fast fingers. Now again, we got to factor in that GC2 actually weighs what? No,
6 point,
GC2.
6 point,
7.50.
no, 7.4. Oh, what am I saying?
Your mental math skills are...
I forgot it's at 5 there.
So, how many graham crackers do we have? 96.8? Which is actually very close to what it says in the package, okay? And then if we set up another proportion, how many moles of s'mores will that make? 11? No way. There's 1 mole of s'mores for every 2 moles of graham crackers.
Sit down, bro. Get on camera. Sit down.
It's not on him.
Somebody? Anybody? Help me out.
48.4.
48.4? So yes, we have enough graham crackers to make 48 s'mores. We have enough marshmallows to make 39 s'mores, but we only have enough chocolate to make 11.8 s'mores. So we're going to run out of chocolate first. Chocolate's going to limit us to a maximum of 11.8 s'mores. Okay?
11 s'mores.
Yeah.
Can't make 0.8.
Can't make 0.8 of a s'more, so 11 s'mores. Okay?
I'll eat it.
So these 2 ingredients we're going to have extra of. What's another word for extra? Surplus. Fantastic word. Chemists don't use it though.
No.
We use the word excess. We're going to have an excess of marshmallows and an excess of graham crackers. We're going to have extra of those left over, right? Okay? Now, one of the things I might ask you to do is to calculate how much extra will we have. Which excess do we want to calculate?
Chocolate.
Chocolate is not the excess. Chocolate we're going to run out of.
Marshmallows.
Marshmallows. Okay, so given this amount of chocolate,
Technically, you have to.
what mass of marshmallows will we have left over? How do we do that? Let me write the question. Actually, before I even answer that, let's finish these two calculations. Because remember, the reason we started doing those is we realized that this was more than the mass of ingredients that we had, right? So let's figure out what mass of s'mores will we actually be able to make. Well, Z grams of s'mores in 11.8 moles of s'mores is proportional to, well, still 46.95 grams in 1 mole. Joshua. Calculate it. The YouTubers are going to have some comments for you, my friend.
Check out that kid in the front sleeping.
It's a knife.
554? Anybody else get that? Okay. So we're really only, when we go to UPS, we're really only going to need to pay for 554 grams of shipping to Mongolia. Because that's as much as we'll be able to make. We're shipping these to Mongolia.
Hey.
Okay? We call this our theoretical yield. That's theoretically how much we should be able to make. Okay? If Justin starts nibbling on the crackers, or when we break them, little chunks go flying off, right? We might not actually get 554 grams, but this is what our theoretical yield should be, right? Anybody ever cook or bake? This yields 5 servings, right? That's how much it should make, but if you got some hungry people, it might only make 5 servings, right? If you spill stuff all over the place, you might not get 24 cookies, even though the recipe says yields 24 cookies. You might only get 23, right? So this is theoretically how much we should make. That's based on our limiting ingredient. Our limiting ingredient is always going to allow us to calculate our theoretical amount we should be able to produce. And this should be less than the total mass of stuff we have, right? What do we have total? 1,300? So yeah. We know we're going to have some left over. We know we're going to have about 800 grams of stuff left over. But that's graham crackers and marshmallows. Now I want to ask the question, what mass of marshmallows will remain? I want to binge on marshmallows tonight. I got all these extra marshmallows. What mass of extra marshmallow calories am I going to eat? Subtract what? Grams of marshmallows minus grams of chocolate? Grams here minus grams there. I would get 1,300. That's more than the total mass of stuff. I can't have 1,300 left over if I put 1,300 in and I'm getting 500 product, right? You gotta set up a proportion.
Oh yeah.
First we have to figure out, given this much chocolate, how much marshmallow will we actually use? don't care how much I actually have anymore.
Oh, I know what you're saying.
I want to know how much we're actually going to use. Well, that's still stoichiometry. Okay? But here's where it's going to be different. I could do this and I could say, okay, let's figure out how many moles of chocolate bars we have, but we already did that. So I'm going to start with this number. I'm going to say 23.6 moles of chocolate bars, and I want to know how many s'mores does that make? Or sorry, how many marshmallows does that require?
Do you want it in grams or?
Well, what do we know about the ratio of chocolate bars and s'mores?
Well, blank of gram of chocolate bar equals 1 mole. I don't know. I have a different proportion on my sheet.
Okay, but I'm asking you to think about this. How can I go from chocolate bars to marshmallows? What, based on what? What is the proportion?
Molar mass.
The equation.
Based on the equation. The equation is the only thing that allows us to change from one substance to another. Now, in all of these steps that I have in blue here, we went from an ingredient to our product of s'mores, right? But there's no reason I can't set up a proportion between chocolate bars and marshmallows, right? What is that proportion?
1 mole of M.
1 mole of marshmallows is proportional to.
1.
We're not going to s'mores
1
anymore.
mole of 2 moles of CB.
We want to go to chocolate bars. So 1 mole of s'mores is proportional to 2 moles of chocolate bars in our recipe. So now I can say, well, I don't know how many moles of marshmallows I need, but I know I have 23.6 moles of chocolate bars. So if we solve this, what do we get? Divide this by 2, 11.8.
3.
11.8.
11.83.
Because this is not divisible by 2, so you got to steal 1 from here. 1.6 over 2 is 0.8. 22 over 2 is 11. What is this number telling us?
Oh, yeah, it's 11.8.
Moles of what? Moles of marshmallows. No, wait a minute. That number, 11.8, sounds familiar. That's right here. But this is?
Number of chocolate that you can make.
This is moles of s'mores we're going to make, right?
Okay.
But since the s'mores and marshmallows are proportional, 1 to 1, however many moles of s'mores I'm going to make, that's how many moles of marshmallows I would have needed, right?
Yeah.
Okay, so I could have gone from here and set up a proportion between the s'mores we made and the marshmallows we need. Okay, all these things are proportional to each other. Okay?
Yeah.
I'm scaling this recipe up. I'm scaling it up instead of putting instead of saying 2 chocolate bars, I'm saying 11.8. Well, if I scale 2 up to 11.8, this has got to scale up to 11.8, right? This would have to scale up to
11.
no. Half of 11.8, right? Something that's proportional to the ratios here. Okay? So now we know how many marshmallows what? What is this telling us? The marshmallows
That you need to make it for.
that we're going to use. To use up all that chocolate, right? But how many do we have to begin with?
39.5.
We had 39.58 moles of marshmallows, right? We're going to use 11.8 moles. So how many moles are going to be left over? Just subtract them.
27.78.
27.78.
27.78. 27.78.
Does that make sense?
Yeah.
So in that bag, when I'm done we should still have 28 marshmallows, right? Unused, left over, right? Because we're only going to use 11.8, and we're going to run out of chocolate. What mass is this? Well, how many grams of marshmallows are proportional to 27.78 moles of marshmallows? I don't know, but I know that
X grams.
7.15 grams is proportional to 1 mole of marshmallows.
$198.627.
Yeah.
So this is how many grams of marshmallows are going to be left over. 198.6 grams. Okay? So those are the typical questions I'm going to ask you. I'm going to give you some recipe or make you write the recipe yourself by balancing an equation. I'm going to give you amounts of ingredients. I'm going to ask you, how much product can I make? Well, you might do multiple calculations. You might get multiple answers. You might get 1858 here and 554 here. Which one's your answer? Whichever one's smaller. I can't make 1,858 grams. I only have enough chocolate to make 554 grams. Right? I might also ask you which one's going to run out. So this calculation actually is telling us, with these two answers, which one we're going to run out of. We're going to run out of chocolate. We're going to be limited to this amount of s'mores, which means chocolate's my limiting ingredient. I might also ask you to calculate what mass or what amount of excess ingredient is going to remain after we use up all of the limiting ingredient. Okay? Well, you have to do a proportion and set up from that limiting ingredient how much of an excess ingredient will you use. Once you figure out how much you used, you can subtract from how much you had. That'll tell you how much is left over. Okay? All right. There's another way to do all these.
You just divide them.
Well, what I did was I kept this reaction in a mole ratio. But I could do something to calculate this reaction in a mass ratio. I'll show you what I mean by that. I can take this recipe. I could say we need 1 marshmallow, 2 graham crackers, 2 chocolate bars, and I get 1 s'more. I can say, what does all this stuff weigh? What does 1 marshmallow weigh?
7. Can you go back to 7.15 grams? That's what you said.
Okay. What does 2 graham crackers weigh?
You said like 7.5 something. Wait.
Well, wait. 7.5 was 1 graham cracker, right?
No.
But our recipe calls for 2.
No, it wasn't. It wasn't. It's only, that was only 1. See, it says 3
Each little piece is 3.75.
times 2.
But my recipe calls for 2 of these.
Oh,
So really what I'm trying to say
14.
is, given the recipe for a s'more,
15 something.
what total mass of ingredients do I need? So really I'm going to factor in the 2 here and the 2 here. So really I need 4 little atomic pieces of graham cracker.
Can you go back real quick to see the measurement?
3.7 times 4?
15 exactly.
15. So it requires a total of 15 grams of graham cracker to do our recipe, right? What about the chocolate bars?
3.7 times 8.
3.10 times a total of 8 little pieces in a s'more, right?
24.8. Oh my god.
Okay, so this is the total mass of things required in my reaction. Now that should equal the total mass we get out, right? What's the total mass? That's what a
46.95. s'more weighs.
A s'more weighs, right? Does this add up to 46.95? It should. Try it. It does? Okay. So this is the total mass equation, I'll call it. Tells us what total masses of things are required, what total masses of things we produce. Now, I could do interesting things with these numbers. Well, they're interesting to me anyway. Now I could say, all right, well, if I have 283 grams of marshmallows, how many grams of s'mores is it going to make? Well, the way I can do that is to say X grams of s'mores is proportional to 283 grams of marshmallows, in the same way that in my equation 46.95 grams of s'mores is proportional to what mass of marshmallows?
Of marshmallows?
Yeah. What mass of marshmallows do I need in my recipe?
7.15.
7.15. What do I get?
You cross multiply on this, right?
Go for it. Calculate.
1,858.3.
That number sounds
1,858. Yeah.
Same number we got the other way.
Bro, I need like express.
Of course we got the same answer.
Yeah. I like to buy one of those.
We're using all the same numbers. We're just doing it in a slightly different way. It just looks different. Okay? You could set it up this way. You could figure out what everything weighs and use the proportion of the weights according to the equation and just go from grams of one thing to grams of another. There's something missing here though. We never actually calculated how many marshmallows we had when we do it this way. We never actually calculated how many s'mores we were going to make. If somebody asked us that, then we got to go back and we got to convert to moles.
Why don't we just divide by the number of grams of s'more weighs?
Oh, we could do that. We could set up a proportion and say, okay, how many moles of s'mores are there in 1,858 grams of s'mores? Well, that should be proportional to 1 mole of s'more weighing, what was it, 46.95 grams. If I solve this, should get 39.58. I was going to do it in check. Same thing we got here, right? Okay, so you could do it this way if you're just trying to get to grams, and then you can use the mole ratio to get back to moles. That's fine. Yeah. Either way you want to do it, right? We could do the same thing with the chocolate bars. 293 grams of chocolate bars. How many grams of s'mores is that going to make? I keep wanting to write SM first. Well, X grams of s'mores per 293 grams of chocolate bars is now proportional. We're just going to use these amounts. What's the proportion? John!
Yes.
Ruining my YouTube video. You're making me angry. People watching are only going to focus on whatever you were talking about, your weekend. You don't want a s'more?
I do.
Then what makes you think I'm going to give you one? What makes you think your behavior deserves a s'more? You're so close to being one of the best students. It's not going to cut it in AP, man. Gotta focus.
Okay.
You just said you couldn't even stay awake.
Something's hurting my head.
Yes, because you're probably using it for the first time in your life.
Oh, boy.
It's like if I go to the gym and I start trying to do squats, I'll be like, oh, my muscles hurt. Why? They don't do squats all the time. So of course it's going to hurt, right? But if I do it enough, I'm going to build those muscles up and it's going to be easy. If you do this enough, you're going to build this muscle up and it's going to be easy.
No, wait, me and Jason already did all these. That's what I'm saying.
Okay, but even if you've already done it, what we're doing here is we're really trying to internalize this, okay? So I need you, even if you did all this, to really stay focused. Please, please, please. Okay, according to this new method of mass ratios, what is the proportionality between the grams of s'mores we get out and the grams of chocolate we put in?
The number of
Look
chocolate.
at our recipe. How many grams of s'mores does our recipe make?
46.95.
And to get that,
You need 24.8 chocolate.
right?
Yeah.
So now if we solve this, it should tell us what mass of s'mores we can make.
How would you 54.69?
Of course it was 554. We already calculated this, right? We're just calculating it in a different way. Okay? How much time does my phone have left? What? You were supposed to give me a 5-minute warning.
It's at 52.
All right.
We have like 14 minutes.
So we could do all these same types of calculations using mass ratios. And if all we're interested in mass, this is a faster way to do it. Okay? Some people don't like this thing going to moles and stuff like that. I mean, at some point you might have to go to moles. Okay? But I'm trying to give you different ways of solving the problem. For some people, setting up the total masses of everything and just using one simple ratio of masses is going to make more sense for them. If it makes more sense, do it. Okay? Whatever way makes more sense to you, that's the way I want you to do it. Okay? It makes more sense not to set up a whole proportion, but just to take a number and multiply by one proportion, do it. Okay? There are even more ways than this to solve these. Okay? And I'm just giving you some options. Now, I really want a quick try, just in a couple of minutes. See if I can apply this to a reaction. At the beginning of this unit, we all took methane and we burned it in our hands. And it produced CO2 and H2O and a nice cool flame that blew up our Snapchat. Everybody's like, oh my god, your hands on fire. Okay, so this is the recipe for burning methane. I could do similar calculations. If I was to, say, take 283 grams of methane and react it with 726 grams of oxygen, let's see, what were the other questions we asked? How many grams of product can I make? Okay, so how many grams, what mass of of CO2 will I make? Well, we've got two ingredients, right? We're going to have to do two calculations. We're going to have to say, given the amount of CH4, how much CO2 can I make? And given the amount of O2, how much CO2 can I make? Do I really have to do that? Isn't this one going to be limiting since we have less of it? Wrong. Look at the example we just did. Which thing had the least mass? Marshmallows. We had the least mass of marshmallows, but did we run out of marshmallows?
No.
No, we actually ran out of chocolate bars. Okay? So it all depends on the recipe. It all depends on what those individual pieces weigh. So we actually have to do the calculations. So here's what I'm going to do. I'm going to say, let's figure out the moles. How many moles of CH4 in 283 grams of CH4? You guys are going to do the calculations. Well, I know that 1 mole CH4, if I add it up using the periodic table, it's going to be about 16 grams. Carbon's 12, hydrogen's 1. 4 hydrogens, 1 carbon is 16. 17.86? Okay, so I have that many moles of CH4, but now I got to get it to CO2. So I have to say, okay, well, how many moles of CO2 are there for 17.68 moles of CH4? Where am I going to get that ratio? Rylan?
Oh, I don't know.
Oh. Just sing the song.
No.
You're gonna get in
Where do I get a ratio of moles?
the equation.
From an equation. The equation tells me a ratio of moles. Here's my equation. My equation says 1 mole of CO2 is produced for every 1 mole of CH4 we put in. So I don't need you to calculate that for me. I'm going to produce 17.68 moles of CO2. Am I?
No.
Maybe. Maybe. We have to figure out, what about the oxygen? Will the oxygen make more or less than that? If it makes more, then yes, we'll run out of CH4. But if oxygen limits us to less than this, then oxygen's going to run out. So, X moles of oxygen in 726 grams of oxygen proportional to 1 mole of oxygen weighs about 32 grams. So how many moles of oxygen am I working with? Come on!
I know. 55.
22 for what?
22.68.
22, boy. 55.
Okay, so now we got to say, okay, well, how many moles of CO2 will I produce for 22.68 moles of O2? Where do I get that ratio?
The equation.
Balanced equation. Equation says 1 mole of CO2 is produced for 2 moles of O2.
11.34.
Ha! We're never going to make 17 moles of carbon dioxide. We don't have enough oxygen, right? Even though we had a way, way, way bigger mass of oxygen, our calculations tell us that oxygen limits us to producing 11.34 moles of CO2. So this is the most we should ever expect to make, right? So I could convert this to grams using the molar mass. I could also set up a ratio and say, okay, well then, if I'm going to have extra CH4, what mass of extra CH4 will I have? Well, if I know I'm going to make this many moles of CO2, I can go from moles of CO2 I'm going to make to moles of CH4 required to make it. That's a 1-to-1 ratio. So it actually requires 11 moles of CO2, or sorry, of CH4 to make the 11 moles of CO2. So remember, we had 17 moles. So we're going to have about 6 moles remaining. Right? If I have 17 moles of CH4, but to make this many moles of CO2, since it's a 1-to-1 ratio, I'm going to need 11 moles of CH4. 17 minus 11 is how much is going to be left over, 6 moles.
6.34.
Something like that. Yep. Okay, and then all those things I can convert back to grams and so on and so forth. Okay, so this is what we're eventually going to do. We're going to do the same sort of processes, same sort of ratios, and using the balance equation, using the molar masses, but we're going to do it for chemical reactions. Cool? All right, let's make some s'mores.
Wait, actually?
Actually.
Like, you don't have to finish it.